Hello, I'm Colin, and I have a question for you. Say I raise 5 to some power, and it evaluates to 25. What was the power? If you said 2, then you're correct, and you essentially just answered what we call a logarithm. So, as you can probably tell, today we're going to learn about logarithms. Logarithms are inverses of exponential functions. So if you're not already familiar with exponential functions, you'll want to watch my video on those first. Okay, so what exactly is a logarithm? Well, to answer that question, we first need to define an exponential relationship between some values. Suppose we have some number represented by the letter a, and let's raise a to a power. Let's say b. And to make this work, we are going to say that a is greater than 0, but also not equal to 1. You don't need to worry about that too much for now, but it is the case that we need to restrict the value of a bit in order to define logarithms generally. More on that in a later video. So back to the scenario we just set up. Remember that when you raise a number to a power, that number is called the base, and the power is called the exponent. Okay, now let's say whatever a raised to the b power is, we'll just call it c. We're now ready to define logarithms. We say that if a raised to the b is equal to c, then that means the logarithm, or log, base a of c is equal to b. Now I want to stress here that this is just a definition. This is not necessarily something you should be able to figure out using logic. This is something people defined. Now that being said, it's a very useful definition for a mathematical function because what it is the inverse of exponentiation, or the inverse of raising some base to a power. In other words, logarithms undo exponentiation. And actually, exponentiation also undoes logarithms. They're both functions, and they are inverses of each other. This is similar to how addition and subtraction are inverse operations and can undo one another, assuming you add and subtract the same number. Or how squaring and square rooting are inverses and can undo one another. In math, whenever we can do something to a quantity, we always want to undo whatever we did. This is why logarithms were defined to be the inverse of exponentiation. So let's get more into logarithms. In a logarithm, the little subscript value is the base, and the number in the parentheses is the input to the logarithm. Now, I've found the best way to think about logarithms is to imagine they're asking you a question. The question the logarithm asks is, what number would you have to raise the base to in order to get the number in the parentheses? For example, if we were given the log base 2 of 16, we're being asked, what exponent do you have to put on 2 in order to get 16? Now we know 2 raised to the 4th power is equal to 16. So clearly, we have to have an exponent of 4 on 2 if we want to get 16. Therefore, the answer to log base 2 of 16 is 4. Let's try another example. Say you're given log base 3 of 1 over 27. To answer this, try reframing the logarithm as a question. what power do you have to raise 3 to in order to get 1 over 27? You can pause the video and try to come up with the answer yourself. Okay, so we have to remember that it is possible to raise numbers to negative exponents, and that the negative sign on the exponent is actually due to a multiplication by -1. And raising numbers to the -1 has the effect of taking the reciprocal of the base. We see this is how we can get 1 over 3 raised to some positive power. Now, we just have to remember what power we must raise 3 to if we want to get 27. And hopefully you remember 3 to the third is 27. Putting it all together, we get that log base 3 of 1 over 27 is -3. Okay, I hope you found this introduction to logarithms clear and helpful. In the next videos, we will learn the properties of logarithms, which make them incredibly useful in mathematics. We'll cover logarithms as functions and the graphs of logarithms and applications of logarithms. All right, I'll see you in the next video.